Hey there, science fans. Today we're diving into the fascinating world of buoyancy. Ever wondered why things float? Why do some objects sink like a rock while others stay afloat? The answer lies in a principle discovered by a brilliant Greek mathematician and inventor named Archimedes, way back in the 3rd century BC. Legend has it that Archimedes was taking a bath one day. As he lowered himself into the tub, he noticed the water level rising. He realized that the amount of water displaced was equal to the volume of his body submerged in the water. This realization sparked a moment of pure genius. Archimedes shouted, "Eureka!" which means "I have found it." This discovery led to what we now call Archimedes Principle, a fundamental law of physics that explains why things float or sink. It's all about the balance between the weight of an object and the upward push from the water, also known as the buoyant force. So, what exactly is buoyancy? In simple terms, buoyancy is the upward force that a fluid, like water, exerts on an object submerged in it. Think of it as the water trying to push the object back up to the surface. The more water an object displaces, the greater the buoyant force acting upon it. Imagine a rubber ducky in a bathtub. The ducky displaces a certain amount of water. This displaced water pushes back on the ducky with an upward force. If this upward force, buoyancy, is greater than the ducky's weight, the ducky floats. But if you place a heavy rock in the same bathtub, it sinks. Why? Because the rock's weight is greater than the buoyant force from the water it displaces. The water just can't push back hard enough to keep the rock afloat. Now you might be wondering why a small rock sinks, but a giant ship made of steel can float. The secret lies in density. Density is how much mass is packed into a given volume. Think of it this way: a fluffy cotton ball and a small rock might be the same size, but the rock feels much heavier, right? That's because it's denser, more mass packed into the same space. Objects less dense than water float, while those denser than water sink. That's why a giant ship, despite its weight, can float. Ships are designed with hollow hulls, spreading their weight over a large volume and making them less dense overall than water. The same principle applies to life jackets. They are bulky and light, increasing your volume without adding much weight, making you less dense and helping you stay afloat. Section 4. The invisible force that keeps things afloat. Buoyant force, the force that keeps things afloat, acts in opposition to gravity. It's like an invisible hand pushing upwards from the water. The strength of this force depends on two things: the volume of the object submerged and the density of the fluid. Think about a beach ball. When you push it underwater, you feel a strong upward force trying to push it back up. This is the buoyant force in action. The larger the beach ball, the more water it displaces, and the stronger the buoyant force. The density of the fluid also matters. Salt water is denser than fresh water, which is why it's easier to float in the ocean than in a swimming pool. The denser the fluid, the greater the buoyant force it exerts. Section 5. From ships to submarines, Archimedes in action. Archimedes' principle isn't just a cool scientific concept, it has countless real-world applications. We've already mentioned ships, which are designed to float based on their density and the buoyant force of water. But what about submarines? How do they submerge and resurface at will? Submarines have ballast tanks that can be filled with either water or air. When the tanks are filled with air, the submarine is less dense than water and floats. To submerge, the tanks are filled with water, making the submarine denser than water, causing it to sink. To resurface, compressed air is used to force water out of the ballast tanks, making the submarine buoyant again. Archimedes' principle is also essential in designing hot air balloons, hydrometers, those instruments used to measure the density of liquids, and even in understanding the behavior of weather patterns like thunderstorms. Section 6. Keep exploring the wonders of buoyancy. So there you have it, the science behind why things float. From the bathtub to the ocean depths, Archimedes' principle is constantly at work, explaining the fascinating interplay between objects and fluids. The next time you see a boat, a balloon, or even a rubber ducky floating, think of Archimedes and his groundbreaking discovery. Keep asking questions, keep exploring, and stay curious about the world around you.